Major James Webb Space Telescope project will map 500,000 early galaxies. The survey has already been running for 2 decades. It's been nearly 350 years since Sir Issac Newton wrote, "If I have seen further, it is by standing on the shoulders of giants," but the sentiment certainly holds true today. Newton's wisdom is exemplified by a grand project called the Cosmic Evolution Survey, or COSMOS. COSMOS builds on the legacy of the Hubble Space Telescope, but NASA's James Webb Space Telescope will continue the observations during its first year of operations in a program called COSMOS-Webb. Founded in 2002, COSMOS originally utilized Hubble to image an area of the sky equivalent to 10 moons wide. The program later grew to include ground-based observatories working across multiple wavelengths of light. COSMOS has become the survey that a lot of extragalactic scientists go to in order to conduct their analyses because the data products are so widely available, and because it covers such a wide area of the sky. Rochester Institute of Technology's Kartaltepe, assistant professor of physics and co-leader of the COSMOS-Webb program, said in a statement. Now, a second space-based observatory will join the endeavor. Over some 200 hours of observation time during its first year, Webb will image 500,000 early galaxies for the survey. It will use its near-infrared camera, NIRCam, to map a subset of Hubble's COSMOS field about 3 full moons in size. Webb will also map a separate, smaller area with its mid-infrared instrument, MIRI. COSMOS-Webb is the next installment of that, where we're using Webb to extend our coverage in the near and mid-infrared part of the spectrum, and therefore pushing out our horizon, how far away we're able to see, Kartaltepe said. The goal of COSMOS-Webb is threefold: to examine the epoch of ionization and the very earliest stars, to search for early, fully evolved galaxies, and to study the evolution of the mysterious substance scientists call dark matter within galaxies' stellar content. Because we're covering such a large area, we can look at large-scale structures at the dawn of galaxy formation, Caitlin Casey, an assistant professor at the University of Texas at Austin and co-leader of the COSMOS-Webb program, said in the statement. We will also look for some of the rarest galaxies that existed early on, as well as map the large-scale dark matter distribution of galaxies out to very early times. Of course, Webb still needs to become fully operational before COSMOS-Webb can proceed. The telescope is currently adjusting its mirror and calibrating its instruments. NASA expects it to begin science observations this summer. James Webb Space Telescope is nearly halfway through its mirror alignment stages. Stars are getting sharper in the James Webb Space Telescope's field of view. The team recently completed the third of 7 planned steps to align the 18 hexagonal segments of Webb's mirror, marking nearly the halfway point in a complex, weeks-long process. The second and third stages were respectively called segment alignment and image stacking, representing larger movements of the main mirror. Subsequent stages will make more minute adjustments to take an image of a distant star and gradually bring it to a single precise point, NASA said in a statement Friday, February 25. We still have work to do, but we are increasingly pleased with the results we're seeing. Lee Feinberg, optical telescope element manager for Webb at NASA's Goddard Space Flight Center in Greenbelt, Maryland, said in the same statement. Years of planning and testing are paying dividends, and the team could not be more excited to see what the next few weeks and months bring. During the segment alignment stage, Webb engineers refined an initial image of a star rendered 18 times. Engineers made minor adjustments to the main mirror and changed the alignment of Webb's secondary mirror. These repositionings were key to overlapping the light from all the mirrors so that they can work in unison, Webb officials said in the update. Then the third stage, image stacking, saw the focus dots reflected by each mirror stacked on top of one another. Photons of light from the individual segments were each rendered to the same location of a sensor on the telescope's near-infrared mirror, NIRCam. The team activated sets of 6 mirrors at a time and commanded them to repoint their light to overlap, until all dots of starlight overlapped with each other, Webb officials said of image stacking. Next will come the fourth phase of mirror alignment, called coarse phasing. That phase is already underway. NIRCam will be used to receive the light spectra, or wavelengths, from 20 pairings of the mirror segments. The process, Webb officials said, will allow engineers to correct small differences in heights between mirror segments. This will make the single dot of starlight progressively sharper and more focused in the coming weeks. NASA officials said, noting that the segments will gradually align to achieve an accuracy smaller than a single wavelength of light.
Well guys, this video is over. I hope you enjoy, and if you enjoy, be sure to hit the like button. Actually guys, if you want more videos about any subject and any topic, please comment. For example, World War III, or I don't know, about extinct of dinosaurs, like this, and some topics like this. So generally I hope you enjoy, and until the next video, have a great time.